Good morning, class. This is the video to show you the inductive decision tree algorithms. This is one of the most popular decision tree algorithm in machine learning. So first of all, let me share with you why do we need to care about these algorithms. Decision tree has been applied in information retrievals, especially the image processing application, such as if you use Facebook, you can see that your avatar photos and the photo that you took with your friends and college use as a training, so that they use it in order to recognize your face and automatically tag or suggest tags in your pictures with others. Or they can also use it in order to verify the login, so you have to log in from a different device also. In image processing or medical field, they also use decision tree in order to build the model for diagnostics of cancer, detecting the cancer tumors and so on. For iPhone applications, they use decision trees for recognizing the objects. So for example, in here, they can train it with a huge library of apples, from Honeycrisp to Gala apples, different kind of apples, and then they can use decision tree to create the model. And when you have a new image coming in that contains the apple, it will automatically recognize the apple in your image. So those are just a few applications of a decision tree algorithms. To show that it is important algorithms, it has some interesting concepts that are useful for learning as a whole. So in the decision tree algorithm, we of course start with a set of features, a set of observations, and then we go to the model builders. And we build the model from that set of observation, your data set. And then after we have the model, we can access the testing data, and then we'll make the recommendation for those testing data. So one of the examples here, this is from the Cornell video PowerPoint slide on machine learning and decision trees. This is the decision tree for Obama Clinton in the 2008 primary. So for example, in here, we can start a decision tree with the question, is the county more than 20% black? If it is yes, then the county has large African American population, then Obama will have no problems in this county to work in this county. Obama will win this county 383-7. So that is the observation. If it is no, and there are not many African American in this county, now we look at other feature. For example, is the high school graduation rate higher than 78%? If it is yes, then this is the county with more educated voter. Then we ask another question, is the high school graduation rate higher than 87% and so on? This is the higher education county if it is yes. Then for those county, Obama wins this county 185-36. So as you follow this decision tree, you can see that how the battle of the primary presidential election in 2008 perform based on the demographic data of a county in terms of race, in terms of education, and in terms of the incomes, and so on. All right, so that presidential data set is very interesting, but it's huge. So we have to start somewhere small first, and then we can go and work with that presidential data set later on, if you like. So here's my toy data set that has only 14 observations, 14 instances, and it has 4 features: the outlook, the temperature, humidity, and windy. It has one class, play or not play. So in this toy data set, we are trying to model the behavior of one tennis player to see how he make decision to play a tennis game or not play based on the combination of the outlook, of the weather, the temperature, the humidity, and the windy. So first we will use decision tree to model his behavior. Decision tree is a tree with 2 type nodes: decision node and leaf node. Decision node represent a choice of some feature with 2 or more values. Of course, if the feature has only 1 value, we don't have to make a decision. We have no other choices. The interesting point is when a feature has more or 2 values. So the leaf node indicating the classification. Now in this case, the decision node is one of those features. For example, the outlook, the humidity, the windy, and in each branch we have the value for that corresponding feature accordingly. So this is a typical decision tree that comes off from that weather data set. How do we get into creating this tree? So this tree is the models. First, we will introduce to you a new concept called entropy. It measures the homogeneity of a learning set. Homogeneity. What it means is that how good is your data set? Informally speaking, for example, if your data set only have one type of observations, one type of instance, is not very good for learning, because you only have one type of observations to relate to. Your experience only contain, let's say, positive instance. Your experience only contain the observation where he decide to play or not decide to play only. That will not helping you to predict whether he is going to not playing if in fact you only observe what he does when he's playing, or vice versa. So entropy allow you to measure that attributes of that characteristic of your data set. The entropy is the real value from 0 to 1. If your data set is so school, then the entropy is close to 0 or 0. If the data set is evenly distributed, then the entropy is close to 1 or being 1. So after we compute the entropy, we can use it to compute the information gain. The information gain is another important concept that measures the worth of a feature, information gain, and how well a feature separates the instances according to their classification. So informally speaking, we have 1, 2, 3, 4 features here. Which one is the most influenced feature to the user decision making? So that one is the one who I focus the most. And so information gain will help me to rank my features based on that measure. So the entropy S, which is the data set, is the total of minus pi, this a proportion, log to a pi. So pi is proportion of each instance in terms of the outcomes. So for example, if we have a play or not play, the minus pi will be a minus p of no play, log 2 of p no play, and minus p play log 2 of p plays. So what is P? P is the proportion or ratio between the number of instances that corresponding to a particular value, for example, the play or not play, yes or no, and over the total number of instances. Now the gain of each data set with regard to each feature is computed as follows: entropy of S, which we just computed, minus the total of the ratio between the SV number of instances with particular value over the total number of instances of S, the entropy of SV, the subset that corresponding to that value only. So, for example, the entropy of the weather data set. Now before we plug it in, I just copy and paste the values into my Excel. So here's my Excel file. And I will start highlighting the instances. So in order to compute the entropies, I need to highlight how many instances that is no corresponding to the no's and how many instances that corresponding to the class yes. So since it's binary, so I can just highlight yellow for all of the things that are no, and I leave the yes unhighlighted. So let me count 1, 2, 3, 4, 5. All right, so go back here. Is 5 corresponding with no, and 9 corresponding with yes, because the total I have 14. Let me make this one subscript so that it so I plug it in, minus 9 over 14. 14 is total instances. Log 2 of 9 over 14 minus 5 over 14, log 2 of 5 over 14, and plug it in Excel. I got 0.94. Now I will compute the gain for each feature. So I take windy feature first. Windy has two values, the weak or the strong. So I will get entropy of S, which is 0.94 that I compute in the step 1, minus how many instances that corresponding to the weak and how many instances that corresponding to the strong. So go back to my Excel. And now let me okay, unhighlight it first. So let me unhighlight it first. So we have
6, 4, 7, 3, 1, 3, 3, 3, 7, 3.
No. We have another. Oh. 3 no's. 4 no's. 4 weeks, sorry. I keep saying no. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 as weak windy, and the remaining is strong. So I put it here, 9 over 14 entropy of S weak minus 5 over 14 entropy of S strong. So how do I come up with this number? First of all, I have to compute the entropy of S weak. So entropy of S weak is what you need to focus on the set that I highlighted here. So instead of focus on the whole 14 instances, I only focus on 9 instances that I have already highlighted it here. So I apply the entropy formula, but I replace it with the highlighted set instead of the whole 14 instances. So what I'm looking for is that I have to count down how many weak and no and how many weaks and yes. So we have how many weak and no's? We have 1, 2 weeks and no, and we have 7 weeks and yes. So therefore the entropy of S weak equal to minus 2 over 9 log 2 over 9, the base is log 2 over 2 over 9, minus 7 over 9 log 2 of 7 over 9, and that is 0.764205. Similarly, I compute the strong, so we'll have only 5, among which 5 we have 2 strong no and 3 strong yes. So I will compute the entropy of S strong equal to minus 3 over 5 multiply on log 3 over 5 log 2 of 3 over 5 minus 2 over 5 log 2 of 2 over 5, and it's 0.70951. And then as you can see, the S strong is pretty evenly distributed. It has 2 for no and 3 for yes. So therefore the entropy is very close to 1. So I just plug it in. I have the original entropy 0.94 minus 9 over 14 times the entropy of S weak minus 5 over 14 times the entropy of S strong, and the result is 0.101958. So I have the gain for that weather set, the S, with regard to the windy feature is 0.101958. So now I would leave it for your practice to compute the gain of humidity or gain of temperature and gain of outlook. Just one hint here, the gain of outlook will be the highest one. So we will choose the highest one as the one for the first feature to split the decision tree. So here's the overall data set. We load the data set. We compute the entropy of the entire data set. And then we compute all information gain for each attribute. We create right here AI with I corresponding with max entropy, max information gain. So we created a root with the tree with the root equal to AI, with the I is max information gain, and all the branch are the value of AI. So for each branch, we create a subset of the data set, of the original data set. So we divided our original data set into the subset, and then recursively apply the whole algorithms for each subset until the entropy for that set is 0. So that is the main algorithms. So the basic idea here is to construct the decision tree by employer top-down, greedy search through the given set of instances to test each attribute or feature at every tree node. So to select the features that is most useful with the high gains information gain, we introduce two concepts, the entropy and information gain. The entropy again is to measure the homogeneity, and the information gain is to measure how well one feature can be split that decision tree up. So as exercise, I would highly recommend you to apply the whole algorithms on this toy data set to verify the decision tree that I have in here. So this should be your outcomes. All right.